welcome back to another episode of the Problem Solving Series. Today we are going to be talking all about elevator problems, which are force problems that take place in elevators. Professors love these problems, mostly because they get a solid concept of physics across, which is F net equals ma, which is very important and probably one of the main takeaways that you want to take out of a physics class is understanding that concept. But there also can be a little tricky just because of the wording. So, in some textbooks, and some professors will define gravitational force and call it weight, which is technically correct. So, weight, when we think about it in physics terms, is the amount that the gravitational pull of whatever planet you're on is pulling on you. However, when you're getting into elevator problems, it's typically the setup is typically that you have a person or an object or something standing in an elevator. The elevator could be accelerating, decelerating, or staying the same, and then they'll ask how the weight on the scale or the scale reading changes. So scale weight is not a measure of gravitational force. Scale weight is a measure of normal force. So that's kind of where it gets tricky, because you might say, oh, well, you're still on planet Earth, so my FG is not changing, so of course my weight's going to stay the same. And again, that would be true, except the problem's not asking for that. It's asking for what the scale reading is, so you would be solving for normal force in that case. Yeah, so professors really love these problems historically. I would bet that there's at least one on any exam that you have involving forces, but we will go into an example so that way you can see what I'm talking about and learn these concepts for yourself and see them in action.
Okay, so let's go ahead and go through a quick elevator problem so that way we could see some of the math in action. A person with a mass of 60 kilograms is standing on a scale in an elevator moving upwards at an acceleration of 1 meters per second squared. What is the measured weight by the scale in newtons? So I'm very obviously wording this problem so that you know that I'm asking for the normal force, hopefully. And that was my whole spiel in the beginning. So, but I'm making it very obvious. Typically, it'll just ask what is the weight, what is the scale say, or something of in that regard. But keep in mind, in the context of this problem, again, we're solving for normal force. So let's write out our mass is 60 kilograms. Our acceleration is 1 meter per second squared, and I drew the picture already, and I just added that the A is going upwards on here. So then we can go ahead and write sum of our forces in Y equals MA. I guess I'll call this AY to be consistent with what I have written there, but we only have one acceleration, so shouldn't be too much of a problem. And then we'll plug in Fn minus Fg equals MAY. Gravitational force is equal to mass times gravity, so I will substitute that into our equation. And then we'll go ahead and add that mg to the other side to get Fn equals m ay plus mg. So I kind of want to pause and just stop here to say when the acceleration is upward, then that means that the normal force has to be greater than the gravitational force in order for that to be true. And you should be able to see from this, I hope, that if the acceleration were downward, that means that the normal force has to be smaller than the gravitational force in order for the acceleration to be pointing downward. So with that being said, a lot of the time this shows up in conceptual questions. So what that means is that going down, the scale weight should go, what did I just say? When it's going down, the scale weight should go down because Fn's lower than Fg. And When it's going up, it should be equal, it should be greater than, and the scale number would go up. And if it weren't moving, it should be the same because A would be 0, and then you just have Fn equals gravitational force, like we typically think of weight. And then I almost forgot to plug in the numbers. And then from here, so 60 times 1, I'm going to use the estimate that g is about 10 meters per second squared, plus 60 times 100 will give us Fn equals 660 newtons.
And there you have it. So that's elevator problems in a nutshell. Like I said in the intro, these are really common. I think it's likely to come up on your exam, so I just wanted to take the time to go ahead and explain in depth the differences and where the confusion can come from so that you guys can all do well. So happy physicsing, and I'll see you guys in the next one. Bye.
Are you awake? You say bye to the kiddos.